Have you ever brought a magnet close to a paperclip and watched as it suddenly jumps, attracted by an invisible force? It almost seems magical. But behind this phenomenon, there's no magic, just an extraordinary property of matter that has fascinated scientists, inventors, and curious people all over the world for thousands of years. Today, we'll take a closer look at what actually makes a magnet attract. Let's start at the beginning. Magnets interact with objects made from certain materials, mainly metals like iron, nickel, or cobalt. But why these materials? The answer lies deep in their atomic structure. Every atom contains tiny particles called electrons. Electrons not only move around the atomic nucleus, but also spin around their own axis. This motion is called spin. And here's where it gets interesting. Each electron acts like a tiny magnet. In most materials, these miniature magnets are arranged randomly, which cancels out their effects. So the material as a whole doesn't show magnetic properties. But in materials like iron, electrons can align in the same direction. When many of these microscopic magnets line up, they form what's called a magnetic domain. And when the domains are aligned, this is when a real magnet is created. It's thanks to this order that a magnet produces a magnetic field, an area around it where a force attracts or repels other objects. And it's this field that's responsible for making the paperclip jump to the magnet. But that's not all. This field doesn't disappear immediately. It extends around the magnet and acts at a distance. That's why you don't even need to touch a metal object. Just bring it into the field's range. It's also important to know that every magnet has two poles, a north and a south pole. Opposite poles attract, while like poles repel each other. If you break a magnet in half, you won't get just one pole. Instead, you'll get two new magnets, each with its own north and south pole. This shows that magnetic properties are rooted deep in the structure of the material, not just on its surface. But how does the magnet know to attract a paperclip and not, for example, a piece of plastic? Again, it's about the properties of materials. Only some materials respond to a magnetic field. We call them ferromagnetic. These materials contain atoms that easily align under the influence of a magnetic field. When you put a paperclip into the field, its own electrons start to align along the field lines, and the paperclip itself temporarily becomes a magnet. That's why it can then attract another paperclip, forming a chain. It's also amazing that there are different types of magnets. We have permanent magnets, like the ones you find on your fridge, and electromagnets, which are created only when an electric current flows through a conductor. An electromagnet can be switched on or off at any time, which makes it extremely useful in many devices, from scrapyard cranes to complex machines in hospitals. Some of the most powerful magnets in the world are found in research laboratories. They're used to better understand the properties of elementary particles and to study matter in extreme conditions. But magnets are also very close to us. In phones, speakers, computer hard drives, or credit cards. Even our hearts can be examined thanks to magnets. That's exactly how MRI scanners work, using strong magnetic fields. Interestingly, the Earth itself is one big magnet. It has its own magnetic field, which protects us from harmful cosmic radiation and allows compasses to work. That's why a compass needle always points north. Without this field, life on Earth would be much harder, if possible at all. Although the phenomenon of magnetism is well described, many of its aspects remain a mystery. For example, the exact nature of the connection between electron spin and the magnetic field is still an area of intense research. We know a lot, but not everything, and that's what makes science so fascinating. To sum up, A magnet attracts because billions of tiny electrons inside it play for the same team. Their coordinated movement creates a magnetic field that can affect other objects, changing their properties. And while from the outside it looks like magic, it's really the effect of precise order at the atomic level. If you want to better understand how the world works and what makes everyday things like magnets so full of mysteries, subscribe to our channel, leave a thumbs up, and share this video with your friends. Maybe they too will be attracted to science.